Kia ora everyone. Today we're going to have a look at identify and locate faults. This one here. This module is our last one. This is our last module on our course. Phew, imagine that, we got there, huh? Once you've completed this one and you've done this test, provided you haven't got anything else left over, then that's it. That's all the theory completed. Can you believe it? After a whole year. If you're sitting there watching this and you are there, that this is the last thing that you've got to do. Well done, congratulations. Don't give up now. The good news, you'll be happy to hear, this module is pretty straightforward. It is almost the same as one that we've done previously, which was locate faults in lighting circuits. Both the content and the test are very similar. I won't cover the same ground again that we have on those ones. If there's any information that you feel like you're short on, go back to that one. That was in module, it was a power conversion, identify faults in lighting circuits. So if you need to revise that one again, please go and do that. As ever, have a look on the Canvas page and check out the YouTube videos there. There's quite a good one where we run through a fairly simple fault finding scenario. Okay, so now this is a very short presentation, but I'm probably going to fill it out a little bit by giving you some more information from my personal experience. To me, fault finding is the essence of being an electrician, in my experience anyway. I've said this before, and I no doubt will say it again, and I don't intend to offend anyone. However, in my experience, in my time, I would suggest that I could train anyone to do house wiring in about 6 months. I could, if we were doing it full time, if I had just me and one other person, and we're just wiring up houses, I could train you to do all of the things that you're going to encounter. There might be the one or two small jobs that I would keep to myself, but in terms of certainly running cables, connecting them to power points and lighting circuits, wiring up your one-way and two-way lighting, building a switchboard is not that complicated. If I told you what to do, it's only a small step from there for you to figure out how to do it yourself. Figure out, okay, I've got this many lighting circuits, this many power circuits, I need these RCDs, I need these circuit breakers. It's not a too big a step for most people to be able to train most people to figure out what cables they want to install. Most of that's pretty standard. Let's do 1.5 for lights, let's do 2.5 for power points, 6mm for your oven, 6mm out to your sub-mains for your garage, that kind of thing. So look, wiring up a house, and this is the, theoretically, if you walk down the street and ask random people, that's what they would tell you electricians do, wire up houses. But I don't think that is massively complicated. Wiring up a house is not something that will take you years and years to learn. So what is it then? Why do we need to serve a 3-year apprenticeship? Why is a Sparky like me, who's done this for 20 years, if you can believe it, superior in most respects to someone who's just finished their apprenticeship or have been doing it for 5 years? What are we gaining over that time that makes us a better electrician? And in my mind, this is a personal opinion, and it's a big topic, but if we condense it down to one thing, it's about fault finding, or at least fault finding. Your ability to fault find is a measure of your skill and experience as an electrician, and your understanding of electricity. That's what this is about, right? If I have a very clear, thorough, and intimate knowledge of electricity, then my fault finding ability is likely to be very good. If I work really hard on my fault finding ability, then my knowledge of electricity is likely to come along in leaps and bounds. And I think throughout the year that we've spent together, a huge amount of the knowledge that I've imparted upon you guys is nothing to do with stuff that I learned at Polytech, sitting in the shoes that you guys are now. But it's been out in the real world, learning and working. And again, I'm not telling you like I've been doing this for 20 years and this is how you strip a cable, this is how you twist a cable. I mean, I have, but that's not the experience I'm talking about. The experience I'm talking about is going and looking at strange things, weird and curly faults and problems, having to sit down and nut things out, design circuits to overcome strange issues, things like that, which have deepened my own knowledge of electricity. And to me, it really all comes down to your fault finding. In that respect, it seems quite appropriate that we would finish on this topic. Yeah, it kind of seems appropriate to me that we'd almost start there, but in a way, if there was something that I would leave you guys on, it would probably be this. How do we fault find? What are we doing? So, look, I'm going to go through the slideshow. Let's do that now, and then I'll just impart some extra things as we go, I guess. So here we have some pictures of some fairly typical faults, or maybe not typical faults, but fairly obvious faults, I suppose. Here, look, we've got a big scorch mark there on the terminal box of a motor. Big melted. It looks like a three-phase breaker. It doesn't look like three individual breakers next to each other. It looks like a three-phase circuit breaker with one of those phases obviously significantly damaged. We've got a burnt out power point by the looks of it there, and same with the light switch there. What does this tell us? Right from the get-go, this tells us that your first and most important tool for fault finding is your eyes. Go and have a look around, because if you walk in somewhere and someone says, well, the motor doesn't work, I push the start button and nothing happens, and you see a big burn mark on the top, and you go and look somewhere else, straight away you've screwed that up. I don't need to tell you that, right? All right. Okay, so our fault finding process, and we talked about this in the last fault finding topic with the lighting. So we want to gather information first, ask as many people as possible who were there, when and how the fault occurred. To me, this is a really important one, and I actually don't think that many people do it very well. Working in the fuel industry, and let me outline a little bit about that in terms of what I was doing. So the vast majority of the time, for probably the 2 or 3 years that I worked as a technician on the tools in the industry, and later on I was a supervisor and manager and various other positions, but certainly in that time that I was on the tools as a technician, the vast majority of my jobs would be, there is a fault at a service station. The service station rings our company up and says the thing is broken, and then a technician such as myself would be dispatched to go and look at it. Now that could be anything. It could seriously anything. It would range from your basic faults where the hoses are worn, or the hose is split. Someone dropped the nozzle and it broke. Mechanical things like that. Keypad's not working on the pump. The lights aren't working in the pump. To the pump's not operating. We pick the pump up, it doesn't work, or I've turned it on in the morning and the display doesn't show up, and something like that. So there's a vast variability in the types of faults. We could also get anything else, really anything else. I fixed leaks in roofs. I fixed lots of lights inside shops. Replaced exit signs. Built a little plywood shelter for a FPOS machine that was out in the rain. All sorts of crazy stuff. So a really good and broad variety of experience, I guess. And so to me, that gather information is a really important one. It's something I learned in doing that job is, if they say the hose is split and you go there and the hose is split and you change the hose, there's nothing complicated about that. But when you do come across something that's a little bit different and a little bit less obvious, then asking the people what happened is your most important thing. You're going to get a massive variability in the quality of information that comes back. So sometimes you have to take it with a grain of salt. I used to interrogate people, especially if it was something that was really, intermittent. Like they said, oh, this happened last night, but now it's working again. Or this has happened 3 times in the last week, but then we just turn the pump off and on again and it works. So when you get there, the fault might not actually be there. So gathering information that becomes your most important step, right? Because like, where do I start? If I turn up and they say the light's not working in the pump, and I look at the pump and the light's not working, that's where I'm going to start. Light's not working in the pump. If I turn up and they say, well, the thing happened, but then it's fixed itself, then I don't even know where to start. So I need to know exactly what happened. I need to know things like, well, what was happening when you did it? Was somebody standing next to it? Was somebody using it? Was it switched on? Was it switched off? Did this happen as soon as you turned it on, or was it working in the morning and then it went bad in the afternoon? And look, I could give you some examples of where that's really important. A super relevant example in terms of that fuel industry stuff is in the first thing in the morning when the pump runs slow. Now, I won't go into details on why that is, but what's happening is pressure drop. You get a pressure drop overnight because everything cools down, and then you have leak detectors and your fuel systems and that sort of thing. But there's two potential causes for that. One is the fact that things are cooling down, and that is a real cause. That's something that is actually happening. But what it can do is that thermal effect can actually amplify the effect of a real leak in the system. And I have done this where I have assumed that fault was to do with a thermal effects overnight, and I ignored it. I went to the site 2 or 3 times and just went, no, it's fine, everything's fine, until I actually went, well, I keep coming back with the same fault. Let me check a bit further, and then found, yes, there was a leak. I don't know how much fuel leaked into the ground in the time it took me from first going to that site to actually finding that fault and fixing it. But I tell you what, that's on my head. I did that. I didn't do my fault finding properly, and now we've had fuel go into the ground, a release of hydrocarbons into the environment due to my laziness or poor fault finding or what have you. So being able to gather that information and ask the right questions and saying things like, does this happen in the morning? Oh, well, when does it start back up again by itself? Or did this happen the night before? Does it happen every day? Those kind of things. And as I said, you might get variable information. Some people got no idea. Sometimes, they'll be honest with you and go, look, I don't know. All I know is someone was using it and then they said it stopped, and that's it. I didn't get any other information. Sometimes they'll be fantastic, especially if they're used to dealing with you. Then they'll know, that guy's going to ask heaps of questions, so I should find out as much as I can while it's happening. I used to have relationships with customers who were really, really good like that. And then you get the odd person who will just bullshit you and go, oh yeah, it did this and it did that, but they don't actually know what they're talking about. So you're going to need to be able to be a pretty good investigator from the point of view of asking the right questions to get the information that you need, but also being able to evaluate the information that's coming back in terms of, is this person being honest with me? Do they even know what's going on? Do they have any idea? And that's something you'll develop over time. It just is what it is. Another funny example I remember is a car wash issue, and they said the car wash wasn't working. So I went in, had a look around, poked around, and found some pretty significant damage. In particular, there was an inch steel shaft that was welded to a surface, and that had been broken off. There was a bunch of damage, but that was the worst thing. Steel shaft broken off. It doesn't fall off, that's pretty serious. And I went and asked the service station owner she was sitting in her office. So I went into her office and she was sitting at the desk. She turned around to talk to me. So her computer was obviously behind her, and I was looking at her with the computer screen behind her. And I said, look, you just said you came in the morning and it wasn't working, but there's some pretty significant damage in there. Any idea what's caused that? This seems a bit odd. Just to add some background to this as well, the contract we had with that site was any wear and tear damage we would cover. They paid us a certain fee per year, and we fixed all the wear and tear damage. If it was accident, it was vandalism or an accident or something like that, then they would pay for that damage. So obviously they had a vested interest in selling to us that it was wear and tear as opposed to an accident or vandalism. And what it looked like to me certainly is that it looked like something shady, like somebody had tried to get their car washed with a boat trailer on or something like that. They dragged a trailer through there, or just something really weird had happened like that. and it really broken this machine. And the lady just said, no, I've got no idea what happened. It was just like that. And I said, well, there's some pretty serious damage, I'm not sure that this is, just general wear and tear. I was trying to be diplomatic, of course. Is there some way you could get some more information about this, like who was on, or perhaps you could look at the video cameras or something and just and see if anything happened at that time. I was at that point thinking, well, if she's saying that there was no accident, then maybe vandals have been in the middle of the night and done it. And she said to me, no, we looked at the video camera, but actually the video cameras don't point that way, and there's just no way that you could see them. Well, as I said, she was sitting in front of her computer, so I'm looking at computer screen behind her, which was scrolling through all of the cameras on the site, and there was just happened, as she was saying, to be one up that was pointed at the entrance of the car wash, and I could see the whole thing. And light bulb flicked on for me at that point. It's like, she's lying to me. She doesn't actually she knows exactly what happened, and she does not want to tell me. So it's an interesting one where, it wasn't just my asking the right questions and stuff. Then suddenly I was confronted with a situation where there was a human element here where I can't use pure logic to work this out. She's actually lying to me and hiding information from me. So you may come across that from time to time. However, as I said, gather information, really important. So then we're going to analyze that information. We'll decide the probable cause based on our past experience and training. So then we will go, okay, well, this is what they've told me. They said this. Well, that means that this is probably the fault here. They said all the lights, the light in the pump doesn't work. Okay, it's probably a faulty lamp in the pump. That's easy. Investigate. So now attempt to find the fault from my analysis. I go, well, I'm going to go and check that light then. And I look inside the pump and I go, oh yeah, that light's burnt out. I rectify it, and then I test. And remember, we must test before we put anything back together. We test it for safety. Follow all of the required safety tests before we put power back onto anything. Okay. So collecting the evidence. This is part of our gathering information. All of the evidence collected must be relevant to the problem at hand. If one is in doubt as to whether anything is relevant, then include it. So if you don't know, you go, there's a scorch mark on the inside of the switchboard. I'm not sure if that is relevant or not because I don't know how long that's been there. You'll open lots of switchboards and find burn marks in there, but that could have been the last time there was a fault or 10 years ago. So I don't know. Well, if you don't know, then include it. Reject it afterwards at the first opportunity if it is clearly not relevant. So how would that become not relevant? Well, then if I asked the owner and went, oh, hey, I saw this big burn mark in there. I'm not sure if that's anything to do with what I'm looking for. Have you seen that before? Is that new? And they go, oh, no, there was the thing that happened 2 years ago, and yeah, that was a totally different thing. Okay, well, now I can get rid of that piece of information. The quantity of information is collected is unimportant. What matters is that all the information collected is relevant. Yeah, we don't want to include anything that is not relevant to us because that's going to lead us down the wrong track. Observe the system running if you consider it safe to do so. If you get there and you find they say the thing does not work, then okay, well, let's test it. Let's turn it on and see what happens. Or it works, but something weird is happening. Okay, well, I need to see that. I need to see the weird thing happening. Unless they say, every time you turn it on, it catches fire. Okay, well then probably I'm not going to turn it on. I want to figure out why it's catching fire without turning it on because I don't want to set it on fire again. So it needs to be safe before I turn anything on to test it. Use all your senses: smell, hearing, touch, sight. Refer to any relevant documentation. And now in terms of assessing whether things are relevant as well, here's something I would just add in there again from my own personal experience, which I don't think is covered here, is try and work out have a look for the common factor, or go to the common factor first. I'm not lying when I say that I've seen Sparkies pulling apart lights because there's 6 lights not working. And they're checking whether there's bad connections. And you go, hold on a minute. there's 6 different lights working and you want to check the connections and the light fittings. What are the chances that yesterday all 6 of those lights were working and then today all 6 of them have had bad connections? That doesn't make any sense, does it? So then your next step would be, well, where are those 6 lights switched from? Oh, they all come from the same switch. Okay, that's where I'm going to go first, right? Logic. We need to use some basic logic here. Look for your point of commonality. If you walk into somewhere and you find that, you know, that all the power points and all the lights in one room aren't working. Well, now I probably want to go back to the switchboard, because it looks like, to me, that certainly sounds like I have a circuit breaker that's controlling all the lights and power in that room, and that's flipped off for whatever reason. I don't want to start pulling apart every power point in that room and every light in that room to see what's happening behind there. That doesn't make any sense. If it was one power point, the opposite is true as well. If there's one power point faulty in a room, they're saying, oh, there's no power out of it every time I plug something in, but all the other power points in the room work. Okay, well then I'm probably not looking for the switchboard, because it seems very unlikely that I've got that power point is on its own circuit breaker and that circuit breaker is blown. It seems far more likely that power point will be on the same circuit breaker as other power points, and if there's only one that's off, it's probably not the circuit breaker. So have a look for that point of commonality. And if you just use that as a concept, you know, I'm giving some specific examples, but if you use that as a concept, you will find it a very useful thing. Like, what is the common feature here? Because sometimes you'll have some things that seem quite different, quite unrelated, 2 faults, and you go, oh, how are these things related? And if you have a think about it and go, well, where is that power from? Where is that controlled from? Suddenly you go, oh, actually, all of these things are all powered from the same emergency stop switch. Okay, let's have a look there. Again, an example from my experience. I hate to bang on about the same things all the time, but I guess the experience I have is the experience I have. If I go to an unmanned fuel site and it's got a card machine with a display and then pumps, if I find that the display is blank and also the pumps are not working, but there's power there and no circuit breakers are tripped, then I think, well, okay, what is the common feature here? It seems, again, unlikely that it's a different fault, 2 separate faults, one on the card reader and card reader screen and then one on the pump itself. What would be the common fault? Okay, so the first thing would be circuit breakers, and I look in the switchboard and I go, no, everything's fine. But then, okay, emergency stop switch. So I've got to think out a little bit outside the box here, because I think my first thought is power to the switchboard, yes. Power in the switchboard, yes, everything's turned on. Okay, well then I should have power at my pump. No. I should have power at my card reader. No. But I've got power on the circuits that go out. Hang on, what's going on? Emergency stop is a safe bet in that scenario. There's another control circuit that is affecting or controlling those things, right? But again, it seems like, if I could say, with the card reader screen and the pumps, are totally separate things. They'd be on separate circuit breakers. The fault in one can't affect the other. They seem totally unrelated. But if I dig a little bit deeper, I find that the emergency stop switch can turn both of them off. So there's my common point. That's where I should be looking. So if we have 2 faults that seem unrelated, look for the common point. Or if we have 2 faults that are related, look for that common point. What relates them together? What brings these 2 things together? Okay, analyze the evidence. Consider all the evidence collected and, if possible, reject any which after further careful consideration is not relevant. Study the hardcore of relevant evidence and, through the process of careful logical thinking, diagnose the likely fault, or at least the area or region of the fault. Yeah, that comes back to what I was just saying. Be logical about this, team. Be logical. Be ruthlessly logical about it. Guessing will very rarely help you and often get you in trouble. Locate the fault. In a sense, this is a continuation of the process of analysis. The areas or regions are systematically reduced in size until a specific part can be identified as being faulty. For example, if a kettle does not boil when it should, it is only by means of a systematic approach that one can determine that the element itself is faulty. Yeah, an example of this in we've done a bit of insulation resistance testing, but I don't know if we've done enough for this to really make sense to you, but never mind. I can do an insulation resistance test on a whole installation by having everything turned on at once, and I just go earth bar to main phase. Well, I have to have the main phase turned off, but earth bar the main phase, everything else turned on, and then if there's no faults in that installation, it'll give me a very high reading in megohms, and I know that it's safe. Now, I've just done the insulation resistance test for the whole installation. But if there's a fault there, that test does not tell me anything about where that fault is. So now I've got to break it down. So what's my next step going to be? Well, the next step would be, okay, I need to figure out which circuit has that earth fault on it. So then I would have to turn off every circuit breaker and then do the same test but on the output side of the circuit breaker. Earth bar to output of circuit breaker 1. Test there. Is there an earth fault? No, that's high reading in megohms. Okay, that one's good. Next one, next one, next one, next one. Until I find the circuit. Once I've disconnected all those circuits from each other, then that one circuit will show up as being faulty and the rest of them should be safe. Okay, I've found that fault, that circuit is faulty. What's next? Well, where is that fault on the circuit? What I may need to do, if that's a power point circuit, say with 10 power points on it, it's going one to the next one to the next one. Let's say I go halfway along, I find the 5th power point of those 10, I pull that power point off, I disconnect the cables inside. Then I can test from the switchboard all the way up to that power point, and then I can test the other cable and go from that power point down the circuit to the next lot of power points. And then I can go, well, it's this side or this side. And slowly you can reduce your size of where that fault is. You can eliminate it bit by bit until you actually find where that fault is. Again, going randomly is probably not going to help you. If I do that test and then I go, okay, it's on this circuit, and then I just go to the first thing on that circuit, disconnect everything and retest. Okay, well, it's still further down the circuit. Well, I go to the next part of the circuit, disconnect everything. I might be there all day because I have to go through the whole circuit, and I find actually it was the last thing on the circuit. Well, but if I go halfway and then halfway and then halfway, then each time I'm getting rid of 50% of the circuit. So I know that 50% of the circuit is clean. The fault is in the other half of the circuit. Okay, well then I take that half of the circuit and I split that in half. And is the fault on this side or this side? Determination and removal of the cause. If the cause of the fault is not removed, the fault will recur even though the fault has been rectified. For instance, a power outlet may have no power and the MCB might be tripped. If the MCB is reset, i.e. the fault of no power is removed, this will not be of much use if the cause of the MCB trip in the first place is not determined and appropriate action taken. Cause of the MCB tripping may be a faulty appliance on the circuit, such as a kettle. This must be removed. Yeah, that's sensible, right? That's sensible. Determine and remove the cause of the fault. If somebody says that, if the MCB is tripped and you're just going to switch it on and go, oh, look, switch, it's coming back on. Sweet, everything is solved. No, something has caused that fault and you need to find out what that is. Every now and then you'll have one that appears to have no cause, and it might be something external, you don't know, but do your fault finding first and figure out, what was it? And again, you're going to be looking for gather information, isn't it? What was plugged in at the time? Did you just switch the kettle on? Did something happen and then it tripped? Now the other thing I'll say here is, I won't say you're guessing, but sometimes you'll analyze and you'll reduce the fault down to a certain thing, and then but you may not know what that is. So again, you might find that circuit breaker trips because the kettle is faulty, but you didn't go into the kettle and find out what was wrong. Well, in that case, throw away the kettle and everything should be sweet. But sometimes, especially if you're doing something a little bit more complicated, I mean, we're talking about a context of a domestic installation where if you're fault finding inside a machine that has complicated parts, switches and circuit boards and electronics in there and that kind of thing, you may reduce the fault down to one circuit board, but you're not going to fault find that circuit board. You just pull that out, put another one in. Now what I say there is, don't guess, but remember that if you go, I think it might be that circuit board, replace one thing at a time. do one thing at a time. If you're rectifying at that point, if you go, okay, well, I'm down to, it's one of these 3 components, but I'm not sure which one. So then you're going to rectify by trial and error, which is valid. I mean, I'm not going to rectify by trial and error if there's 89 things that might be wrong. I need to bring that down. But if I get down to like 3 things and it's going to take me longer to identify which of those 3 things it is than it would to just swap them, then I'm going to do my fault finding from that point by trial and error. I'll swap them out, and then if it works again, okay, now we're good. But don't swap out all 3. Go one at a time, because otherwise you're going to put 3 new parts in there, and then you go, I don't know which one it was, and you're going to have to put the old parts back in one at a time to see if the fault comes back again. So when you're rectifying stuff, and this comes up more often than you would think, and I've done it so many times, I'm a dumbass. It's like, I'll get this idea in my head and go, okay, it could be this, or it could be this, or it could be this. Well, if I just adjust that and change this over, and I've got an old one of those in my van, which I'm pretty sure is good, so I'll swap that over. And then you do that real quick, and then you switch everything back on and go, cool, it works. Right, what was the actual fault? I have no idea. So don't be dumb like me. Don't get excited like I do and start racing off and doing all sorts of things. Again, be ruthless and logical. Okay, let's replace this part first. Right, switch on. Okay, that didn't do anything. Right, I'm going to get that good part out again, the one I just put in, put the old part back, then I move to the next thing. Rectification of the fault. This may be a simple task as in the case above, or it may be a much bigger one. Whatever the case, it is a specific task based on earlier findings. Yeah. Fix the thing that is faulty. That's actually the easy bit, right? The fault finding, that's the easy bit. Once I've figured out the fault, this is easy. Oh, the cable's broken. Okay, now I need to replace the cable. The PowerPoint's broken. Now I need to replace the PowerPoint. It's figuring out what was wrong. That's the hard bit. Check the system. It is important to do all installation testing required by legislation. It is also important to ensure that the machine, equipment, or system is functioning normally after the cause of the fault and the fault itself has been dealt with. In the case of the tripped MCB, it is easy to confirm that the cause of the fault and the fault itself, the faulty appliance, has indeed been dealt with satisfactorily, assuming that the MCB does not trip again. With more sophisticated equipment or systems, it may be necessary to fine-tune the system in order to return it to optimal working conditions. Yeah, that'll be based on experience. Like, I'm not going to tell you in a 30, 40-minute video with a PowerPoint presentation, how to fix all faults on a fuel pump, and it's a whole job by itself being a fuel pump technician. Trust me, I can't teach you how to do that now. It will come with experience and time. So don't expect that. What I'm trying to say is, don't be disheartened if you go out into the world and you find that, okay, I've got some basic fault finding skills, but I've got no idea what I'm doing here because this is very complicated. That is something that you'll deal with as it happens. Techniques for collecting evidence. Look, we've gone through most of these, so I'll just go through it quickly. Observation. Use your senses to observe what's going on. Okay, we've talked about that. Simulation. Is it possible to go through the process and simulate the conditions before the fault occurred? That is something that I would do if it is an intermittent fault, or if it's a fault that only occurs in under certain conditions. I want to try and simulate those conditions. If they say it only happens in the morning and I just cannot figure out what's going on, well, then my next step is, well, let's turn everything off and I'll go away and I'll come back in the morning and you guys do your normal thing and I'll see what happens. I'll watch you. So if we simulate the conditions or observe the conditions directly. Measurement. The basic tools for fault finding an electrical circuit is a basic digital multimeter, which will enable you to check your voltage, amps, continuity, and resistance. For more advanced fault finding, a scope can be used. I've done some fairly advanced fault finding and never had to use a scope. I suppose some people will. Your multimeter, continuity and voltage, those are your 2 big things. I tell people fault finding, 90% of fault finding actually is voltage in, voltage out. Is there voltage into this thing? Yes. Okay. Is there voltage out of this thing? No. All right, that is the thing that is broken. Identification of function loss. Identify what is working and what is not. For instance, a hoist motor may go down with no issues, but it will not go up. Okay, so if they say the hoist is not working, all right, then the hoist is not working. But if they say the hoist works, but it will go down but not up, okay, I'm looking for a different thing. So I need to know what do you mean by it's not working. Comparison. And so actually, again, as I talked about earlier, the person who's running the thing might not know. They're probably not as skilled as you are. So they won't always know. They'll just go, I don't know, it's not working. Well, you might have to do that yourself and go through and run the thing and figure out, oh, hang on, some of this is working, some of it's not. What are the things that are not working? Because once you've figured that out, that's going to tell you what your fault is. Comparison. Does a machine appliance identical to the one with the fault behave in the same way? What current is being drawn by an identical motor with the same load? Yeah, that's a great one. Something I used to do, again, looking at that fuel industry example. Perfect, right? Because I can go, well, this pump here does not work. Well, there's 4 other pumps on the forecourt that are exactly the same. So if it's something like, a great one is programming, right? All of these things have a processor in them, and you have to program them so it knows things like how many nozzles does it have, and how does it turn on the motors, and what pump number is it, because it's got to communicate with the computer. It's got to tell the computer, this is my pump number. I'm going to sell $20 worth of gas to this guy. I am pump number 2. So that when you walk into the shop and you go, oh, $20 on pump number 2, then they know, they can see that transaction. So if a pump loses its program, if you don't have that written down, sometimes that can be quite difficult. But I could go to the pump next to it and go, well, what's the programming in this one? And then usually work out from there what I need to do for the one that I'm working on. Previous fault data, including frequency of occurrence. How often does a fault occur, and under what conditions does it occur? This is actually one for if you're a scheduler or a manager. This is really, really important, right? Something I've encountered a lot in the past as a manager or supervisor is that we'll end up having 4 different people going and looking at the same different fault across a month, and then it's not until somebody comes back and goes, this is, oh, they said that such and such went there, and then everybody starts talking to each other, and you realize, oh, like 4 different guys have been there and they all found the same thing, but nobody fixed it properly, obviously. But if we had been talking to each other, or if the person who's dispatching the technicians remembers, that guy went there last week for a similar fault, I'll send the same person again. Manufacturer's documentation and diagnostic data. Manufacturer's guides often have common faults and methods to diagnose and repair common faults. This is something for you guys that will be very, very different in your career than it has been in mine. So in my career, this what I would call it a database of knowledge, right? So we're talking about manufacturer's documentation, diagnostic data. So it's a database of knowledge. In my time, most of my time as a technician, that database of knowledge existed in my colleagues' heads and in mine, and in books. So the books were a little bit eclectic. If you found one day, like the setup manual for a PEC 8000 pump, and you're like, oh, cool, that's really handy. I will keep that. Great, you have that now, but everyone else might not have it. Someone else might have a book that you don't have. We used to have a quick setup and fault finding guide, which was made by the company, and it had some basics on the different types of pumps and that kind of thing. But I can remember once trying to figure something out, rang up one of my mates and said, man, I'm really struggling with this. And he go, oh, we'll look at page 6 of the setup book. And I said, I look there and there's nothing there. And he's going, no, it says da 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 da. So I followed what he said, and the next time I seen him, I said, show me your book. And I looked, and I had version 4 and he had version 10, and I had no idea that there were any other versions after my one. So he had different information to me. So, we had what was in people's heads. So it was about ringing people, who you knew and that kind of thing. Like sometimes you would be struggling with something and you'd talk to someone and they go, oh, actually, if you ring Dave in Rotorua, he's the guy that knows. It's a real guy, Dave in Rotorua, top bloke. I'd ring Dave in Rotorua, he's the guy. And so you'd ring Dave in Rotorua and go, oh, I'm having this fault. I never met this guy, I don't know who he is. And you have a yarn to him and he goes, yeah, do this, do that. And wicked. But then next time I know, what if I have an issue with this specific thing? Dave's going to be the guy I call. So that was how that worked for me. That was the database of information. For you guys, it'll be different because the world is different now. The last time I was driving around pulling things apart and fixing stuff would have been as a full-time job would have probably been 2011. So nearly 10 years ago, and the world is different now. I can guarantee you that if I started doing that job again now and I was struggling with stuff, a quick Google scan around on YouTube, and I would be finding a vast amount of skill and experience codified on the internet that just did not exist before. So that would be my first step every single time. Find the part number of the thing that I'm looking at, or the serial number, or the manufacturer's model number, or whatever. Google that, manufacturer name plus that model number, and see what comes up. Guarantee you that in the vast majority of cases, that company will have a manual of some description on their website. There may even be fault finding and repair videos on YouTube. There's probably going to be all sorts of stuff out there. Built-in diagnostics. Automated systems with other types of electronics such as frequency drives and PLCs will often have a fault code come up, which can be checked against the manufacturer's instructions. Yeah, sure. So if you get a fault code, start there. That should be logic. But again, people do strange things. Okay, standard and fundamental faults. Loss of supply. Why? Loose connection, tripped circuit breaker, blown fuse, or internal fuse. Earth fault, tripping the circuit breaker or RCD. The device will not re-engage, or it will for a short while and then switch off again. Then it's probably a switched circuit containing the fault, so it's not till somebody switches that particular circuit on that the fault occurs. Dead short, so phase to neutral or phase to phase, has the main protective device at origin activator. So have I blown the pole fuse or the main fuse coming into the house? Correct protective device in place. Do I have the right breaker? A type B, C, D. Remember, these are like motor rated or normal duty, that kind of thing. Defective components, switches, relays, and contactors. They're good ones because they've got moving parts in them, so they're more likely to fail than, for example, unless somebody does something to it, a cable is not probably going to break. And there's cables out there right now that are probably nearly 100 years old that are functioning perfectly. Not much is going to happen to that thing unless a rat chews it, or someone drives over it, or chops it with a shovel or something like that. But if you have components that have moving parts in them, they will probably wear out. Switches and relays and contactors are not going to last forever. Breakdown of control circuits, internal wiring, PCBs and electronics. Reverse polarity at supply origin. At a single outlet or a single fitting. You need to do a live test versus a dead test. Initial faults on newly installed work. Reverse polarity, discrimination, loose connections, protective devices, faulty portable equipment. This is not going to be wear and tear, right? Yeah, it won't be wear and tear because this is new stuff. That's it. That is the end of the presentation. As I said before, if you're looking for a bit more information, we've gone through a lot of the same stuff, and I probably would have said some different things, different emphasis in the faults and lighting. Faults and lighting unit that we've done earlier. All right. Last thing from me. As I said, this is the last PowerPoint that we will do. Congratulations on getting to the end of it. Well, it feels a bit weird that I'm speaking to a computer, but I guess computer and whoever you are staring at your screen behind the computer, this is the last time we will do this. So thank you for everything that you've given me and the time on the course. I've really enjoyed it, and I hope that you've got something out of it as well. As ever with these videos, if you're struggling with anything, feel free to get in touch. I'll help you out where I can. And I'll say on this one, anytime in the future. If you're one of my students, if you're somebody that I know, don't underestimate the strength of the relationship that we have. I will remember you for the most of the rest of my life, probably. So in 2 years, 3 years, if there's ever something I can help you out with, just pick up the phone and give me a call. I'm certain that I'll be glad to hear from you. Alright, team. Well done for the last time. Thank you very much. See you, bye.